The S.T.E.M Ecosystem Project is a 2-year project that's funded by the federal government through the Office of Learning and Teaching. The idea is to build up student and staff capabilities using the multidisciplinary projects across science, technology, engineering and mathematics, or S.T.E.M.
So the Katherine project is a project essentially aiming to improve the water system of 2 communities in the Northern Territory.
And we're looking specifically at trying to improve their water supply and sanitation systems.
So we're looking at designing a system that's cost effective and most importantly that meets the requirements of the local community, and of course it has to have a sustainable approach to it.
The main stage is to fix the pumps and the septic tanks over in the communities.
So there's 2 communities. They both have issues with their water system. One has a pump that keeps breaking down, and the other community has this creek that they use everything essentially for.
So to do this, we got students from environmental engineering, mechanical engineering, from health sciences, from environmental sciences, so a range of different discipline areas. They work together to provide a solution.
The beauty of the Katherine project is that there are multiple challenges facing these communities, and we need to design a system and a solution that encompasses all of those and takes care of all of those concerns.
And it was a real eye-opener for the students to see how much they could learn by working in this truly multidisciplinary environment.
Some of the challenges that we've faced are the remoteness of the community that we're operating with.
The main healthcare concerns in the Katherine community are ear diseases, throat diseases and diarrhoea.
So then there's like the culture, there's the social, there's just the physical environment itself, and also the number of people.
Being issues to do with water, sanitation and health, you do need a system that's going to cover all of those.
You could come and put together this really complicated system, but then it's like, is it fitting for that community? You know, that's the things that you kind of have to consider.
So what we're trying to do is come in and address some of those issues, as well as trying to build trust in the community, because a lot of the time they have people come in and then they don't see the work through.
But you can also see an upside in that there's so much potential to go in there and make a big difference.
Teamwork. You'll see that across all universities now. But the teamwork is normally teams created with students enrolled in the same program within the same discipline. So this is where these multidisciplinary teams differ.
When anyone looks at a particular problem, if you're from a different background or have a different focus, you're going to look at it from a different point of view, come up with different ideas.
Coming into this project knowing that I was going to be working with health students and sustainable systems, as well as a variety of other disciplines, I found really quite interesting and a great opportunity.
This project, we're all from different backgrounds, so like a plumber, an engineer, and me as a health student. So we all come together within our different careers and we're able to put into place what's best for that community and for that person.
Engineering isn't specifically and isn't only tackling the problem itself. It does require a multidisciplinary approach. You do need to work with other people, whether it be labourers, whether it be other specialists, and especially the community in which you're operating.
Working together in truly multidisciplinary teams requires this concept of distributed leadership, where each member of the team provides a particular strength.
At first, I didn't really know what it is that I would be doing as a health student. I thought it would be more of like the plumbers and the engineering students that would do the initial work kind of thing. But then what I've come to learn is that like health students are actually a really essential part of this process. Like we do the promotion, you know, we bring ideas about how to sustain this whole thing about just like the social and behavioural aspect of it.
So my role was more as a probably project manager, but it was important not to lecture to them. It was important to kind of develop their ideas.
The strength of that teamwork is even greater when you have people from those different backgrounds and who notice different things in a problem and can put forward different things in a solution.
These students came together as a team and came up with a solution that was presented at the World Expo in Perth.
We developed a series of customer and non-customer requirements in what the design would address, and then moving on from there we then used sort of all of our expertises, so from the different kind of areas and disciplines that we work in, to then kind of come up with how we were going to achieve these requirements.
So we were able to put in place like a bike being used to generate an alternator, which then helps towards the water flow being sent towards the basin and the toilet.
So yeah, I look at it for the potential issues, so like the possible illnesses they can get from drinking this water, whereas like, because I had James in my original group and I think he's an engineering student.
One of my group members is from health sciences. We were very focused on it flushes toilets and you drink it, and then apart from that we couldn't really get to further uses, but she kind of pointed out that there's a variety, so hand washing and showering and clothes washing, and just the list went on and on and on. One of the biggest problems I think with engineers is we tend to think we know all the answers, and we tend to have very one-focused, a very one-track mind.
When I think of the idea of engineering, I think something really complicated and big, and and then for me being a health student, I don't know much of that, so I always thought it was like the big things like using rainfall or like solar power. But yeah, so it was really interesting, like, seeing a bike or just simple hand pumps and stuff, and how it's actually really easy.
Then I can follow onto my path, which is getting the healthy water put across to the community so that they can benefit their health overall.
The best way or the best outcome that you could possibly get is if you get people from different disciplines or backgrounds of knowledge to come and actually work on this problem together.
So the next point now is looking at refining those systems, making them more efficient, making them more cost effective, making them more sustainable.
This project has really helped me prepare me for the workplace. So often when filling out job applications, that sort of thing, they ask for, or they list teamwork as a very important thing. So this kind of working in a multidisciplinary team to approach a problem and develop a solution, I found has been really beneficial.
So this is really ideal setting for us as student engineers going forward, because we know that once we graduate and once we work for engineering firms, once we work for Engineering Without Borders, we're not just going to be working with engineers, we're going to be working with all sorts of disciplines.
So the experiences that you're able to take from this project and put it into place later on in life, it's a great opportunity.
This is what employers are looking for, and this is what employers tell us that is sometimes missing.
On a more personal level, I found this to be quite a rewarding challenge.
It's motivating to be able to help someone.
I found the team an amazing kind of dynamic and great success, and then I'm really glad to see that this is actually going to make a difference in people's lives.
And this is what's really exciting about this project, that we're getting these teams together, and you can see by the students talking about the projects that they're learning something very valuable that I don't think they've ever got before and that most students don't get.